Hello, in this video I'm just going to talk a little bit about how to label the sides of a right triangle. And although I'll touch on a standard triangle, meaning that it's on a circle, what I'm talking about are free-form triangles. Okay. All right, so if you'll recall from SOHCAHTOA, you know, the definitions of cosine, sine, and tangent relative to the terms adjacent, opposite, and hypotenuse. And I haven't put the reciprocals in here. The reciprocal of cosine is secant. The reciprocal of sine is cosecant, and the reciprocal of tangent is cotangent. And that's been covered a lot in another video. All right, so when I go to label, and by the way, use these probably the most because that's the buttons you have on your calculator. All right, so let's say I go to label a triangle, and I have a triangle here, and I'm gonna kind of make it like this. Okay. And my right angle is going to be where my vertical and horizontal line come together. So there's my right angle. And remember, the hypotenuse is always across from the 90-degree angle. Always. That's not going to change. So here would be my hypotenuse. Okay. Now, let's suppose I label these. Let's say I label this alpha, which is for the Greek letter A, and beta, which is the Greek letter B. Now, it really depends how I'm going to label opposite and adjacent. Really depends on which angle I'm looking at. So, for example, if let me redraw it so you see what I'm talking about. Redraw this, and I'm only looking at, for example, beta. Okay, so here's my hypotenuse. That doesn't change. But relative to beta, across from beta is the opposite. Right? And then here is the adjacent. Okay. But if I instead said, well, actually, let me look at this relative to alpha. Okay. Then here is the hypotenuse again. And now we're going to put alpha in here. And relative to alpha, across from it is opposite. And then here is the adjacent. Okay, so notice that it seems to flip. You know, this side here is the opposite relative to beta, but it's the adjacent relative to alpha. And that's because it's relative. These definitions that you see here are relative to the angle that you're working with. So you just have to be careful about that and keep that in mind. Now, where that changes is when you standardize. So this was what I call, let me just label that, what I call a free-form triangle, right triangle, right? But let's say instead I'm looking at a circle, right? And now all of a sudden, you know, I have an XY axis. See, that's the standardization that starts occurring, right? And then you rotate a certain amount. Let's say I rotate over here. I'm in the third quadrant, but here's my terminal side of the angle, right? Then what happens is you're told the reference angle. It all comes down to the reference angle. And again, I have videos on this, and I'm just putting this in here so you can contrast the two. You can check out the videos on reference angles and really go into this more deeply. But the angle that you're looking at, that's the reference angle for this right triangle, is between the terminal side and the x-axis. So let's say I call that here theta then. And then there's a very specific rule that says the point at which the terminal side intersects the circle, you drop a perpendicular to the x-axis right here, okay? And because of that rule, there's only one way to label the sides of the right triangle. So here you have the hypotenuse, different color, across from the, right, which is across from the 90-degree angle, which is your radius of the circle. And then across from theta you have here is the opposite, but it'll always be the y coordinate, right? If I'm accessing this point, I go x, y. And then here is the adjacent, and it is the x. So because of that, you have this, because of that definition, you have a certain standardization, and therefore you no longer have this relative idea. And as I mentioned in the video, if I were to drop to the y-axis, this would all flip, right? But because of the rule, we all do it the same way, okay? So I think that's it. Thanks so much for listening.